Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss quadrilaterals. In this chapter, we are going to discuss the concepts of exercise 8.1. In the previous class, we have discussed some concepts, some points in this exercise 8.1. I hope you have learnt well. I hope you understood well that points. Haven't you, my dear children? Right. Now come to we discuss some more points, especially the points related to parallelograms, because this entire chapter based on parallelograms. That is why we concentrate on properties of parallelograms. Okay, my dear children, are you ready to listen the class? Right. Come to these properties of parallelogram. Okay, my dear children, you have to learn well these properties of a parallelogram. Without knowing which, you can't solve the problems in the exercise easily. Okay, my dear children, listen carefully these properties of a parallelogram. See the adjacent figure here. ABCD is a parallelogram I have taken. First property, a diagonal of a parallelogram divides it into two congruent triangles, namely, that is here, suppose if you take diagonal AC, if diagonal AC, if you consider AC is the one diagonal that divides the parallelogram, this notation denotes a parallelogram. Okay, my dear children, this notation denotes a parallelogram ABCD into two congruent triangles, namely triangle ABC and triangle CDA. That is, therefore, triangle ABC is congruent to triangle CDA. Okay, my children, if you consider this diagonal only AC, then we get two triangles, triangle ABC, triangle CDA. These two triangles are congruent. Similarly, if you consider diagonal BD, here diagonal BD also divides the parallelogram ABCD into two congruent triangles, namely triangle BCD and triangle DAB. If you take this diagonal BD, then this diagonal BD divides triangle BCD and triangle DAB. These two triangles are also congruent. Okay, my children, understood this point? Yes. Now come to the next property of a parallelogram. In a parallelogram, opposite sides are equal. That is, AB is equal to CD, AB is equal to CD. These two are opposite sides. And similarly, BC is equal to AD. Okay, my children, you have to remember these properties well. Okay, my children. Right. Come to the next property. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Sometimes you have to prove that a quadrilateral is a parallelogram. If you want to prove that quadrilateral is a parallelogram based on the sides, then you have to prove this statements. What is that statements? Opposite sides of the quadrilateral is equal. A pair of opposite sides of the quadrilateral is equal. Then automatically the quadrilateral is said to be a parallelogram. This is just converse of this point. Okay, my children. Suppose this is a quadrilateral. If you want to show that, if you want to prove that this quadrilateral ABCD is a parallelogram, then we have to prove that AB is equal to CD. Okay, my children, and BC is equal to AD. Then we have to prove that these two parts. If you prove the two parts of this quadrilateral, then automatically the quadrilateral is said to be a parallelogram. Okay, my children, understood this point? Right. Now come to this property of a parallelogram, my children. In a parallelogram, opposite angles are equal. This point also we have discussed in the previous class. Do you remember that points, my dear children? Right. Suppose ABCD is a parallelogram. I have taken ABCD is a parallelogram. So in the parallelogram ABCD, angle A is equal to angle C, angle A is equal to angle C, and angle B is equal to angle D. Opposite angles are equal. Okay, my children, remember these points. Remember these properties of a parallelogram. Now come to the next point. Just converse of this point. If in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. See this figure. In a quadrilateral ABCD, if angle A is equal to angle C, if angle A is equal to angle C, and angle B is equal to angle D, angle B is equal to angle D. If these two conditions are satisfied by a quadrilateral, then the quadrilateral is said to be a parallelogram. Okay, my children. Suppose in a quadrilateral, if you want to show that, if you want to prove that quadrilateral is a parallelogram based on angles of a quadrilateral. In the previous point, in the third point, we have used the concepts based on the sides. If the opposite sides of a parallelogram, if each pair of opposite sides of a quadrilateral is equal, then the quadrilateral is said to be parallelogram. Similarly, if you want to prove that, if you want to show that the quadrilateral is a parallelogram based on with the help of angles only, then we have to prove that each pair of opposite angles, each pair of opposite angles is equal. Then it is enough. It is enough to prove that the quadrilateral, in the quadrilateral each pair of opposite angles are equal. Then automatically the quadrilateral is said to be a parallelogram. Okay, my children, understood this point? Right. In the previous points, we have discussed the properties of the sides properties of a parallelogram and angle properties of a parallelogram. We have discussed. Now come to diagonal properties of a parallelogram. Diagonal properties of a parallelogram. See this point. The diagonal of a parallelogram bisect each other. The diagonals of a parallelogram, the diagonals of a parallelogram bisect each other. See this adjacent figure. Here ABCD is a parallelogram. AC is one diagonal and BD also one diagonal. Let the diagonals AC and BD intersect at P of the parallelogram ABCD. Then AP is equal to PC, AP is equal to PC, and DP is equal to PB. These two conditions satisfies. Okay, my dear children, understood this point. Conversely, see this next point. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. In a parallelogram, diagonals bisect each other. Understood this point, my dear children? This point also we have discussed yesterday in the form of table. Do you remember that points, my dear children? Right. Converse of this point, the diagonals of a quadrilateral bisect each other, then the quadrilateral is said to be a parallelogram. If you wanted to prove that a quadrilateral is a parallelogram, if you wanted to show that the quadrilateral is a parallelogram based on the diagonals, with the help of diagonals, then we have to show that the diagonals bisect each other. Suppose the diagonals AC and BD of a quadrilateral ABCD intersect at P such that AP is equal to PC and DP is equal to PB. We have to show these two conditions. If these two conditions are satisfied by a quadrilateral ABCD, then the quadrilateral ABCD is said to be a parallelogram. Understood this point, my dear children? Right. Now come to the next point, last point. Another condition for a quadrilateral to be a parallelogram. This is another condition. If you want to prove that a quadrilateral is a parallelogram, we can use this condition also. What is this condition? A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Okay, my children. In the previous points we have discussed each pair of opposite sides is equal. Each pair of opposite sides is equal. But here only one pair of opposite sides is equal and should be parallel. Then the quadrilateral is said to be a parallelogram. Suppose in this quadrilateral ABCD, if AB is equal to CD, only this pair, we have taken only this pair, only one pair of opposite sides. These two sides should be equal, and if they are parallel, then automatically this quadrilateral is said to be a parallelogram. Otherwise, we can show that we can use this condition also. What is this condition? BC is equal to AD. This pair of opposite sides, only one pair, not two pairs of opposite sides. In the previous points we had discussed, each pair of opposite sides is equal. Then the quadrilateral is said to be a parallelogram. But here only one pair of opposite sides should be equal and they should be parallel. Okay, my children, understood this difference between the previous points and this point. If BC is equal to DA, this pair of opposite sides, only this pair of opposite sides, we are not considering this pair of opposite sides, only this pair of opposite sides. If this pair of opposite sides is equal and parallel, then this quadrilateral ABCD is said to be a parallelogram. This is also another condition for a quadrilateral to be a parallelogram. Okay, my children. With the help of these points, with the help of these concepts, we solve the problems in the exercise 8.1. Okay, my children. Right. The concepts of the exercise 8.1 were finished. Okay, my children. What are the points are related to exercise 8.1 that were discussed, that were completed? Okay, my children, with the help of these points, with the help of these concepts, we solve the problems in the exercise 8.1. Okay, my children, let us start the problems in the exercise 8.1. Right. See page number 146 in the textbook. Okay, my children, come to the question number 1. The angles of a quadrilateral are in the ratio 3 is to 5 is to 9 is to 13. Understood this point, my children? Right. Find all the angles of the quadrilateral. Then we have to find the all the angles of the quadrilateral. Understood this question, my children? Right. What is given here? The angles of a quadrilateral are in the ratio 3 is to 5 is to 9 is to 13. Okay, my children. Let us consider for our convenient ABCD is a quadrilateral. Let ABCD is a quadrilateral. Let ABCD is a quadrilateral in which angle A is to angle B is to angle C is to angle D is equal to 3 is to 5 is to 9 is to 13. Okay, my children, we are assuming that in this quadrilateral ABCD, the angles of this quadrilateral ABCD means angle A, angle B, angle C, angle D are in the ratio 3 is to 5 is to 9 is to 13. Okay, my children, understood this point. Also, what is the angle sum property of a quadrilateral? Yes, do you remember that point, my children? Angle A plus angle B plus angle C plus angle D is equal to 360 degrees. This is angle sum property. This step is nothing but angle sum property of a quadrilateral. Okay, my children, understood this step? Right. Now, come to this ratio. Let us find the sum of these ratios. Now, sum of the ratios. Sum of the ratios is equal to 3 plus 5 plus 9 plus 13. Okay, my children, let us find the sum of these ratios. 3 plus 5 plus 9 plus 13. What will you get? 3 plus 5, 8. 8 plus 9, 17. 17 plus 13. What will you get? 30. Okay, my children, understood this? And the sum of the ratios. Therefore, angle A is equal to how many parts will take angle A? 3 parts. Out of these 30, 3 parts are angle A. So 3 by 30 into 360 degrees. Okay, my children. 3 by 30 into 360 degrees. Then here 0, 0 gets cancelled. 3 once, 3, 12 times. 12 threes are 36. So angle A is equal to 36 degrees. Understood this angle A, my dear children? Right. Similarly, we find the remaining angles also. Angle B is equal to how many parts? Angle B, 5 parts. Out of 30 parts, 5 parts are angle B. So 5 by 30 into 360 degrees. 0, 0 gets cancelled. 3 once, 3 12 times. 5 12 60 degrees. This angle is angle B is equal to 60 degrees. Understood this angle B, my dear children? Right. Now angle C. How many parts angle C? 9 parts out of 30. So 9 by 30 into 360 degrees. Here 0, 0 gets cancelled. 3 1 times, 3 12 times. 9 into 12, 108 degrees. So angle C is equal to 108 degrees. Understood this angle C, my dear children? Right. Now come to last angle, angle D. How many parts angle D? 13 parts. So 13 by 30 into 360. 0, 0 gets cancelled. 3 1 times, 3 12 times. Multiply these two numbers. 12 3s 36. So 156 degrees. This is angle D. Okay, my children, understood angle D also? Right. Like this, we have to find the angles of a quadrilateral. Understood, my children? Right. Now come to the question number 2. If the diagonals of a parallelogram are equal, then show that it is a rectangle. Okay, my children, understood this question? Actually, in a parallelogram, what is the properties related to diagonal of a parallelogram? Yes, diagonals of a parallelogram are not equal. Do you remember this point, my children? Right. But if the diagonals of a parallelogram are equal, then we have to prove that the parallelogram is a rectangle. Okay, my children? Right. Now, let us assume that this is a parallelogram ABCD. In the adjacent figure, come to the solution part. In the adjacent figure, let ABCD is a parallelogram in which AC, in which diagonals AC and BD are equal. That is AC is equal to BD. It is given that in this parallelogram ABCD we have taken the diagonals AC and BD are equal. That is AC is equal to BD. Okay, my children, understood this point? Right. Now we have to prove that ABCD is a rectangle. RTP means required ABCD is a rectangle. Okay, my children. Required to prove. RTP stands for required to prove. R stands for required. T stands for to. P stands for prove. Understood this point, my children? We had to prove that ABCD is a rectangle. Okay, my children? Right. Now come to the proof. Here, let us take triangle DAB and triangle ABC. Okay, my children? Triangle ACB, triangle ACB, in triangle ACB and in triangle ACB and triangle BDA. Let us take these two triangles. Triangle ACB, ACB, triangle BDA. We have taken these two triangles. Actually, this is a parallelogram, so these two sides are equal. Isn't it or not, my children? Opposite sides of each pair of opposite sides of a parallelogram is equal. So, AB is equal to BC, AB is equal to DC, and BC is equal to AD, because opposite sides of a parallelogram they are. Okay, my children. Now, if you take a triangle ACB, let us draw these two triangles ACB, ACB, ACB. Triangle BDA, triangle BDA, BDA. I told you, my dear children, you have to take the vertices of these two triangles in the same order. Okay, my children. Now, here AC is equal to BD, because here we have taken the diagonals are equal. AC is equal to BD. Next, BC is equal to DA. BC is equal to DA, because they are opposites. BC is equal to DA. Similarly, AB is equal to BA. Okay, my children? Right. Now let us compare the corresponding sides of these two triangles. AC is equal to BD. AC is equal to BD. Already we have taken. Okay, my children. Given. That is a given condition. AC is equal to BD. Next, BC is equal to DA or AD. BC is equal to AD, because this pair of sides, it is a one pair of opposite sides of a parallelogram. Opposite sides, these two are opposite sides of a parallelogram, is BC and AD. Okay, my teacher understood this point, understood this step. Next, we have taken AC and next BC. Next, AB is equal to BA. AB is equal to BA. That is common side. Okay, my children. After comparing the corresponding sides of these two triangles by SSS congruency criteria, what can you say about these two triangles? These two triangles are congruent. Okay, my children. Therefore, triangle ACB is congruent to triangle BDA. Triangle BDA by SSS rule. Simply I am writing here by SSS rule. Means by SSS congruence rule. Okay, my children, understood this point? Right. Since these two triangles are congruent, the corresponding angles are also equal. isn't it or not, my dear children? Right. So angle A is equal to angle B. Angle A is equal to angle B. Means angle CAB. Angle CAB equal to angle C is equal to angle D. Okay, my dear children. This angle equal to this angle. So angle DAB, angle DAB equal to angle CBA. I am taking these two angles. Okay, my children. These two angles. Angle DAB and angle CBA. So angle DAB is equal to angle CAB. Angle DAB equal to angle CBA. Angle CBA by CPCT. Do you remember this word, my children? What is the full form of CPCT? Yes, corresponding parts of congruent triangles. Okay, my children? Right. So angle DAB is equal to angle DAB is equal to angle CBA. Okay, my children? Right. And moreover, these two angles are with respect to parallelogram. These two angles are consecutive interior angles, isn't it or not, my children? Angle DAB and angle CBA are consecutive or alternate interior angles because BC is parallel to DA, isn't it or not, my children? Or interior angles on the same side of the because BC is parallel to, if you take this pair of parallel lines BC and DA are parallel because it is a parallelogram, isn't it or not, my children? So if you take BC and DA are parallel lines and AB is a transversal, then these two angles are interior angles on the same side of the transversal. Then what can you say about interior angles on the same side of the transversal? Yes, they are supplementary, isn't it or not, my children? This implies angle DAB plus angle CBA is equal to 180 degrees because interior angles on the same side of the transversal is supplementary. You have to remember this property also, my children, in the parallel lines. When we are discussing parallel lines, this is one of the properties. Interior angles on the same side of the transversal is supplementary. So these two angles are interior angles on the same side of the transversal. If you observe, if you take AB as transversal for these two parallel lines BC and DA, okay, my children, right? This implies actually angle DAB is equal to angle CBA. Both are same, isn't it or not, my children? So angle DAB plus angle CBA, sorry, angle DAB is equal to 180 degrees because let us consider this as result 1. So from 1, we assumed this result as 1. So from this result 1, angle DAB plus angle DAB is equal to 180 degrees. Understood this step, my dear children? Right. So from this step, what will you get? This implies angle DAB plus angle DAB. What will you get here? 2 angle DAB is equal to 180 degrees. Isn't it or not, my dear children? From this step, what will you get? Angle DAB plus angle DAB is equal to 2 angle DAB is equal to 180 degrees. Okay, my dear children? Right. This implies, let us transpose this number 2 to RHS. Then what will you get? Angle DAB is equal to 180 degrees by 2 to 1 times 290 times. So this implies angle DAB is equal to 90 degrees. Understood this step, my children? Right. Therefore, angle DAB is equal to angle CBA is equal to 90 degrees. Because from the equation 1, angle DAB is equal to 90 degrees. But angle DAB is equal to angle CBA. Both are equal angles. They are equal to 90 degrees. So this is 90 degrees and this is also 90 degrees. So we can say that the parallelogram is a rectangle. Therefore, parallelogram ABCD is a rectangle. Okay, my children, understood? Right. Now, come to the next question. That is question number 3. Show that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. Understood this question, my children? If the diagonals of a quadrilateral bisect each other at right angles, we have to show that the quadrilateral is a rhombus. Okay, my children? Right. Come to the solution part. Let us take a rough diagram. This is a quadrilateral ABCD in which we have taken AC diagonals AC and bisect each other at right angles at this point O. Okay, my children. In the adjacent figure, let us consider the diagonals AC and BD of the quadrilateral ABCD bisect each other at right angles at the point O. Understood this point, my children? Right. Now let us take these two triangles AOD and triangle AOB. In triangle, now what is to be proved? We have to prove that. Required to prove ABCD is a rhombus. If this condition is satisfied, we have to prove that that is a rhombus. Okay, my children. First, let us write the steps which are. So here OC AO is equal to, that is AO is equal to OC, AO is equal to OC, and OB is equal to OD, and OB is equal to OD. Okay, my children. And AO is perpendicular to BD, and AC is or AO. AC is perpendicular to BD, or AO is perpendicular to BD. Both mean the same. Okay, my children, from this data, I wrote these steps. AO is equal to OC because they are bisecting at this point. So this part equal to that part. Similarly, OB is equal to OD, and it is a perpendicular. They are bisecting each other at right angles. Understood this point, my children? Right. Required to prove. Required to prove. What is to be proved here? ABCD ABCD is a ABCD is a square. Okay, my children. Right. Now come to the proof. Let us take AOB, triangle AOB, triangle AOD. Let us take these two triangles. Okay, my children. Triangle AOB and triangle AOD. Okay, my children. Let us take these two triangles. Okay, my children. Right. Now let us draw the rough diagrams of these two triangles. AOB, 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 AOD, AOD. Okay, my children. Let us compare the corresponding sides of these two triangles. Okay, my children. Now AO is equal to AO. That is common side. That is a common side. AO is equal to AO. Next, OB is equal to OD. OB is equal to OD. Because they are bisecting, the diagonals are bisecting. OB is equal to OD. Here we have written OB is equal to OD. Given, that is a given condition. Okay, my children, understood. OB is equal to OD. We used this result here. Okay, my children. Next, angle AOD is equal to angle AOB. Angle AOD, this is right angle. Angle AOD is also right angle. Angle AOD, AOB is equal to angle AOD, 90 degrees. So, by which congruence rule, these two triangles are said to be congruent triangles? Yes. Yes, yes. Isn't it or not, my children? Therefore, triangle AOB is congruent to triangle AOD by SAS, congruence rule. By SAS congruence rule, these two triangles are congruent. Then automatically, what can you say about these two sides? These two sides are also equal, corresponding. AB is equal to AD. AB is equal to AD. Isn't it or not, my children? AB is equal to AD by CPCT. By CPCT. Understood this step, my children? By CPCT, these two sides are also equal. So in this quadrilateral, we have proved that these two sides are equal. Similarly, if you take these two triangles, AOB, BOA, BOC. If you take BOA, BOC, then we can prove that these two sides are also equal. Similarly, if you take these two triangles, angle COB, angle COD, then we can prove that this BC equal to CD. Okay, my children. So we know we are not proving all these parts. So simply we write similarly. Simply we write here similarly. We can prove that AB is equal to BC, BC is equal to CD, AB is equal to BC, BC is equal to CD, CD is equal to DA. Okay, my children, we can prove by taking these two triangles and by taking these two triangles, by taking these two triangles, then we can prove all these statements. Okay, my children, it is no need to prove all these statements. Okay, my children, understood this one? Right. Therefore, in this quadrilateral ABCD, all the sides are equal and the diagonals are bisecting each other at right angles. Then what do you say about the quadrilateral? Then it is a rhombus. Isn't it or not, my dear children? Therefore, quadrilateral ABCD is a rhombus. Okay, my dear children, understood? Right.